Welcome back, my dear students. In continuation of that IC engine chapter, now we will study the details about the working of 4-stroke petrol engine here. As I have told, stroke means what? Stroke length. Stroke length L means it is the distance between the linear distance between the TDC and BDC here. Maximum distance that a piston can move here. So that stroke length here, based on that stroke we can classify 4-stroke and 2-stroke. What are the 4 strokes are taking place here in this case here? So in case of the 4 strokes means the stroke 1 will takes place, it is called as the suction stroke here. Suction stroke, this is one here, and the second one is here now. After that the suction stroke, the compression stroke here, compression here, and third one is here. After the compression here now, it is the power stroke here now, or expansion stroke, power stroke, or sometimes it is also called as the expansion stroke here now, and fourth one is it is called as the exhaust stroke here. These are the 4 strokes are taking place in a cycle here. So it is in a one cycle here. In one cycle, these all 4 strokes will taking place. So by the movement of the piston and rotation of the crank here. So how this one? So first one is a suction stroke. Suction means fuel is entering, fuel plus air is entering, and compression means it is a compressed, means pressure increases and the volume decreases here now. And power stroke means the conversion of the heat energy into that rotary mechanical energy. That is the conversion will be takes place here. Main important, that is the power stroke is taking place here now. And exhaust stroke means, as I have told, after that combustion, that the gases are there, the waste gases are there, that has to be released to the outside here now. That is the exhaust stroke here now. All these strokes will be takes place one by one. There will be the sequence. Sequence is suction, compression, power stroke and exhaust stroke. Like this, in this the sequence only the strokes will takes place here now. It is a sequence here now. So next one is a cycle, means if all these 4 strokes will complete, then it will be called as a one cycle here now. So in case of this the petrol engine, the cycle will be operated, that cycle is called as the Otto cycle here now. So based on the Otto cycle, this will be happened here now. Now we will study diagrammatically how these 4 strokes and cycles are happening along with the Otto cycle in PV diagram, that is a pressure and volume diagram here. So next, what I will take here now, simple line sketch I will take here now. So one position of the piston we will start. What we will start here now, we will start in case of the 4 stroke, we will start with the suction stroke we will start here now. So therefore here, so this is the cylinder here, yes, this is the cylinder here, this is the crankcase here now. Small figure I will draw very small. So here for 4 stroke I will draw that 4 same kind of the figure I will draw here. Same 4 kind of figures I will draw it here. So quickly I am drawing here. Same kind of figures has to draw 4. So this is the arrangement of that crankcase and the cylinder arrangement here now, how I am drawing here. Next, as it is required, the piston position for the first stroke, that the piston position I will take at the top dead center here. This is the top dead center, that the piston arrangement I will take it here now. I will draw a center line here. here is the, it is what here now? Crankshaft here now. In a line, this crankshaft has to draw here now. So next one is, as I have told, this is a gudgeon pin and this is the connecting rod here, and the here in this case, and this is the that is a crank here in this case here. So what is happening here now? Now it is a piston is at a TDC here. This is the BDC here in this case here now. So inlet valve now at this first stroke here in the suction stroke, this inlet valve is there, it's open, and outlet valve is closed here now. This is the exhaust valve, it is a closed one, and the inlet valve IV, it is open, it is open here now. So what happens in case of the PV diagram here? Just I will draw this PV diagram somewhere here. I will draw it just to see this. P is in vertical axis and V is in horizontal axis here. So what happens here now? When the piston is at top dead center in the first stroke, inlet valve is, that is a closed, open, and exhaust valve is closed here now. So next what happens? When the piston will starts moving downward here, it starts moving downward towards BDC here now. What happens? What happens here now? Here pressure will reduces, suction will creates. So how this piston will move? Who will move that one? Energy is required to move here now. Energy is, it is stored in the previous stroke in case of the flywheel, as I have told, or else it can be motorized here now. Some electrical motors are used to start the engine here now, nowadays here now. So therefore motor, it may be motorized, it may be in case of the continuous cycles, it is stored in the flywheel. By that energy, the piston will move from the top dead center to bottom dead center. Even it is moving toward. When it is moving towards this one now, so what happens here now? Because inlet valve is, it is open here now, fuel plus air here, very important, fuel plus air. In case of the petrol engine, fuel and air are there proportionately mixed here now. Proportionately mixed. In case of the carburetors, it is proportionately mixed here now. Atomization and mixing will be takes place. That well mixed fuel plus air, it is coming through this inlet valve here now. Why? Outside is a higher pressure, inside is a suction. It is a negative pressure, lower pressure. So therefore fuel will move towards this in the cylinder here in this case here now. So this is called as the suction stroke. How we can show here now? In this is a suction stroke here now. This is a suction stroke. How we can show here now? This can be shown like this here. This is the process here now. S and 1 here. S and 1. S to 1 is a process here. So therefore the fuel plus air is start entering here now. In the next here. In the next that what happens? When the piston will comes at the bottom dead center here. Yes. When the piston will comes at the bottom dead center, as we have to draw the center line here now, that the crankshaft has to draw here in this case. So next, where that connecting rod and crank position, I will show it here now. It is moving like this. It is moving like this. Here. Here. Right? So now this crank will comes here. So it is at the bottom dead center now. BDC. It is the bottom dead center here now. So next, what about the valves here? Now in this next stroke here, both the valves are there. Both the valves are closed here now. So showing of this inlet valve and exhaust valve, whether it is open or closed, it is very important in case of the diagram. In this stroke here now, in this stroke is called as the compression stroke. This stroke is called as the compression stroke here now. In this stroke, inlet valve and exhaust valve, both are closed here now. And in between these two, there will be the spark plug here now, SP. In all the cases, there will be spark plug here now. In all the cases, there will be the spark plug SP here. In case of the petrol engine, there will be the spark plug here in this case. So both the valves are closed here now. This is closed here and this is also closed here now. Then the piston will start moving from bottom dead center to top dead center here, TDC here. How it is moving now? again that movement of the piston from the bottom dead center to top dead center in the compression stroke by the motorization, or else that it will take the energy from the flywheel here now. Any one of these two will happen here in this case here. So next what happens, these two valves are closed, piston is moving here now, whatever the fuel plus air is there here now, it is a fuel plus air, it is also called as a charge. Charge means it is a mixture of fuel and air, petrol and air here. So when this piston is moving upward, this will be compressed here. When it will be compressed, its compression ratio will be increases. As I have told CR, it will move in case of the petrol engine 4 to 10, up to 10 compression ratio. 10 times it will be compressed here now. So once it will be compressed, how we can show in the PV diagram here now. This is the PV diagram. In this case, we can show like this here now. This is the pressure, that compression here. It is 1 to 2 here. 1 to 2. It is the compression that process. In this compression process, what is happening here now? See this, pressure is increasing, volume is decreasing here now. This is a volume here. Volume is decreasing. Once it is compressed, its volume will become small, pressure will be increases. Like this, it is happening in this line here now. So now at the point 2, it is a compression stroke, fuel plus air will be compressed. And the next, in case of here, in the third one is what here now? After this compression, something will happen here. One, this piston is at a top dead center here. Both the valves are also closed here. Both the valve, inlet valve, outlet valve, both are closed here now. So in that cases, what happens here in this case here? See this one now. Here, at this stroke, here in the third stroke here now, the spark will be generated. Means sparking will take place. After that sparking, ignition will start here now. So that the spark will be generated. That is called as the heat addition process here now. That spark will be generated. That spark will be generated at a constant volume process here now. So therefore here, when the piston is at top dead center, at a constant volume process, this one, at a constant volume process 2 to 3, that heat is adding, the spark will be taking place here. So once that highly compressed charge, spark has been added to that, then what happens? The flame will propagates, combustion reaction will start, large amount of the heat will be released here now. So therefore, then what happens here now? Then what happens? It will apply that energy, high fluid gas. It is having energy. It will apply certain pressure force on this piston. Then piston will start moving downward here now. So when the piston will start moving downward, we can draw it here like this here now. So like this here now. So in this case, energy is developed here now, because heat as a added, combustion reaction is taking place. That heat energy is converted into what here now? Work here now. So therefore, this stroke is called as the power stroke here now. Power stroke, or else it is also called as the expansion stroke here now. So therefore, this is the expansion stroke here now. In this expansion stroke, what it is happening? When the piston is moving from the top dead center to bottom dead center, its pressure is decreasing, volume is increasing. When the piston is moving down, its volume will be increases and pressure will be decreases here in this case. So therefore, this is called as the power stroke here now. How many revolutions of that crank connecting this crank has been made here now? Here it is a half revolution. Here it is another half revolution. One revolution has been completed here now. Here is another half revolution. 1.5 revolution here now. So in this 1.5 revolution, we are getting one power stroke here now. Still this cycle has been completed here now. Another one stroke is there, that is the exhaust stroke. That exhaust gas has to go out here now. So next what happens here now? So here in this case, so we will draw that the piston at the BDC in this case here now. At this BDC, in this case, inlet valve remains closed, outlet valve is there, open here now. This is open here now. So next one is here. This is a crank here. I will draw it like this. Here like. So in this case here now, in this case what happens here now? In this case what happens? Exhaust valve is open and inlet valve is closed here now. What happens? The piston will move up here, move up by the stored energy once again here now. So when it is moving up here, exhaust valve is open, the exhaust gases are there, they will go out here now. So they will go out when that process is constant volume process here in this case here now. 1, 2, 3 and 4 here now. 4 to 1 will be taking place. While it is starts moving, again it will take place 4 to 1 and 1 to S here. 1 to S. Total from 4 to 1, 1 to S is the process where that exhaust gas is going out here now. So therefore, this cycle is called as the this stroke is called as the exhaust stroke here in this case here. So therefore, total all the 4 strokes are completed, but how many revolutions of the crank has taken here now? Here is 1 revolution, half revolution, half revolution, half revolution, half revolution. Means after 2 revolution of the crank, we are getting only 1 power stroke here now. So therefore, this is the 4-stroke working cycle. We will see in the next video lecture just continuation of this here. Thank you very much.